Okay, good afternoon, everybody. It's our pleasure to have once again another talk of the immuno webinar series. And today we have the pleasure to receive Dr. Ulisses Gazos, that is a full professor here at the Biophysics Institute of the Federal University of Rio de Janeiro. He's also head of the Molecular Parasitology Lab. And Ulisses graduated in biological science from the State University of Rio de Janeiro, got a master in parasitology from the Federal University of Minas Gerais, and his PhD here from the Federal University of Rio de Janeiro with a sandwich period at the Harvard School of Public Health. He did his postdoctoral fellowship at Dana-Farber Cancer Institute at the Harvard Medical School, and he was also a visiting researcher at the Pasteur Institute in Paris. And when he was a fellow of the senior internship program abroad from campus. He has major experience in molecular parasitology, molecular biology of parasites, and cell signaling of these cells infected by pathogens. Ulisses also has a very large experience in supervising students with former students of his in several of the most important institutes in Brazil. And so thank you very much for accepting our invitation. It's really a pleasure and a treat for us to hear you talk today of games parasites play, the NF-kappa-B, HDAC1 transcription regression in Leishmania malignancies infection and beyond. Thank you, Dr. Ulisses.
Thank you very much for the kind words. Thank you for the invitation. Great. It's a great opportunity to share some results with you, with people from Institute Sensible Water Approach. And today I will release some previous work of my lab, my group. And also I will have some more recent results. And the main interest is trying to understand is emission mechanism that Leishmania malignancies is able to implement when it is in contact with the cell with macrophage. The type of games for that play, by the way, is was inspired paper in the 80s, published in Science, and that's taken was kind of the people of the escape mechanism of Leishmania that was known to. And I thought that it could apply for this talk. Okay. Okay, so for those that are not used to Leishmaniasis, so Leishmaniasis is a very important disease. It's a neglected disease found worldwide, and you see that Brazil is a hotspot in prevalence.
I just want to ask you to speak a little bit louder and maybe a little bit more in front of the.
Okay. So I was saying that Leishmaniasis is a very important neglected disease, and you see that Brazil is a hotspot area of transmission and with a high prevalence, high incidence. And you see here it is a report from WHO. This prospect shows some problems and some things that are important in terms of research and development in Leishmania. So this WHO material is showing that people when they live in this area of Leishmania transmission, there is a kind of aggravation of Leishmania, mainly visceral Leishmania, with a co-infection with the HIV. And that is here what's important, that there are several challenges and research and development is a must when you think about approaching Leishmania. And there is some successful stories like the limitations of Southeast Asia. And here you have some numbers, and for those that we interested in Leishmania, that stress how important it is the disease. So, for those that are interested in this research, Leishmania is said to be a regulatory infectious disease worldwide, is a complex model of pathogen-host interactions. So, it's kind of an interesting issue for system biology, for example. In this kind of context, we also can understand the reprogramming of self-host expression and on the other way, also the expression of the pathogen, or as the Leishmania in the case. And by studying those points, you may find some very good implications or potential implications that can explain pathogens, and it can also be applied in the treatment of Leishmania. So the cell cycle is comprised by two forms of the parasite. This form is called promasidotes. This promasidote form is found inside the vector with a cell fly in the individual of the insect, but it replicates and migrates to the front part of the gut, and it is transmitted by the bite. Inside the host, those promasidotes form penetrating macrophage. They replicate inside a parasitophage vacuum, and you see here the amasidote form, which is the parasite with a very tiny flagellum, and this kind of environment is quite important in terms of communication between the parasite behavior and the cell and the nuclei of the macrophage infected. So here is a more descriptive life cycle. You see that these promasidotes, which are competent for invasion and replication, the metacyclomasidotes, they get in touch, they contact neutrophil cells. They are able to penetrate neutrophil cells, and these neutrophil cells can of extracellular traps, neutrophil cellular traps, which is probably a mechanism of control of the infection. On the other way, these neutrophils could be apoptose, the phagocytes by macrophage, and then there's replication inside the macrophage. There's a lysis of the macrophage, another cycle of infection, and then with another another Leishmania bites the host, is able to undergo the cycle inside this base. There are several critical forms of infection, and that will depend of, for example, of the species, also the response of the host. So have a limited cutaneous form that's caused by those species that you can see here. There is very severe mucocutaneous forms of infections, mainly due to a group of parasites, the Vivianus genus of Leishmania. There is this necrotelus form of the infection. It's rare, but it's very important. So those patients, they don't have a late specificity response. Those models of pool parasites and they lack this Th1 response to the infection. And it's the visceral leishmaniasis caused by two species of Leishmania, and the infection goes to liver, bone marrow, and spleen patients. So there is still this paradigm of the control mechanism of leishmaniasis, of cutaneous leishmaniasis, and you see here is the control, which of course we have this INOS expression, increasing levels of nitric oxide, and that is imparted by gamma interferon production, and that leads to activation of the macrophage. On the other hand, we can have this more Th2 response and polarization of macrophage for MA2, and then instead of INOS expression, we have arginase expression, and there's no or very limited nitric oxide production, but there is this level of polyamines. So this is a parasite survival branch, and there is the control of parasite infection. Of course, things are much more complicated than that, and mixed profiles can be found in infection by different species of Leishmania. So here, just depicting this onset and they have the infection, we also have the defects in contact with receptors in macrophage. Okay, have either INOS production, nice INOS expression, a nitric oxide production, or the arginase pathway, we have polyamine production, and also the repair mechanisms of injured tissues. So, in this what shows our important research in investigating leishmaniasis. In this review, she shows the main features of leishmaniasis infections when found in macrophages, in the cells, and CD4 positive T cells. So what is strengthened is the repression of the activation. A lot of these players in these two onsets of infection, which is control or which is this survival mechanism of Leishmania, so several cytosines and also ILOPs. The expression is controlled by a main transcription factor is NF-kappa B. So we decided some time ago to investigate NF-kappa B activation in the context of Leishmania infection. And what you see here is that the NF-kappa B is a transcription factor. It was one of the first transcription factors described in the late 80s by the Baltimore group. And NF-kappa B can be activated by several different similar in controls expression of the flora of GNT blood inflammation, cell survival, in the regulation of NF-kappa B itself. And that's the most that shows the importance of this transcription factor in several different contexts. So the NF-kappa B family is comprised by several members, and what you see here those that there's Hellway P65, and that's one important member of the NF-kappa B family that generalizes with P50, And what I'd like to show here is a common feature of NF-kappa-B which is a Helmholtz domain. In this Helmholtz domain, there is the region of binding DNA and also utilization of the different components of the NF-kappa-B family. So what you see here in green is a nucleus localization sequence, and in those pieces 5, CL and LB, you see the carboxyl terminal is starts with a transactivation domain. P50 and P52, they are parts of, they are originated by the processing of precursor with a P105 and P50, and processing of P100 that leads to P52 formation. So this processing is obtained on to proteasome cleavage. And as you see, P50 and P52 lacks the transactivation domain. So here there are several possibilities of dimer formations that can be found in nature. So the most known NF-kappa-B dimer and the most studied is canonical LA of IBCCF-UFRJ, but there are several others, as you see here. So those dimers, they contain these tags with a transactivation domain that recruits RNA polymerase 2, while those here are repressor, where P50, P250, P252, when they are formed, they lack the transactivation domain. So they are able to bind to 6 hormones, but are not able to lead to transcription. Those here, they are not found, they have no DNA binding activity. It's questionable they are found in nature. So NF-kappa-B activation is also controlled by inhibitors of the NF-kappa-B. In this case, we have this family, I-kappa-B alpha, beta, and also the precursors that I mentioned before, P105. They have this anchoring sequence, and they are able to bind to dimers and separate them in the cytoplasm when there is a stimulus, so those dimers can be translocated in the nucleus, find the sequences in the promoters, and then leads to expression of some genes. So basically, you have 2 pathways of NF-kappa activation. You have the canonical pathway, which is kind of related to receptor, like tau receptors or NF receptors. There is a kinase complex, IKK, that's phosphorylates I-kappa-B alpha, that's polybutylated, integrated, and then dimers go to the. And here it's a non-canonical pathway that's more related to developing the immune system, and we are not talking about it today. So NF-kappa-B activation was described a long time ago by different patterns like Leishmania, toxoplasma, bacteria, E. coli, and also virus. And so some time ago, we decided to understand the dynamics of NF-kappa-B activation when you have infection by different species of function. So this slide shows George say when you have the nuclei of infected macrophage that are labeled and that are incubated with a labeled probe, and they migrate native molecular gel. And you see here 1 hour of interaction that you maintain with the macrophage, you have this main bank, and you perform the superficial phase with the specific device. You see this there is superficial by P65, which is divided against P65 and against P50, which means that in this many title, at least in our system, leads to the formation of P65-50, which is the canonical Leishmania amazoniae, the canonical NF-kappa-B diagram. With the Leishmania lesion, I have a similar frame. So in one-hour interaction with a macrophage, we see these two bands that are shown here. And by superficial stage, you see P65 and P50, we have a similar result. But and with the Leishmania amazoniae are kind of different. So this shifter stage showed that only P50 is actually found in nuclear effective macrophage. So it means that P50 in the whole dimer form is found when Leishmania amazoniae interacts and invades macrophage. So if you remember, P50 lacks the target domain, so we expect that it's going to be a repressor of consumption. So we decided to test this hypothesis. What we did was intubate macrophage with an inducer of the canonical NF-kappa-B pathway, which is LPS. So when you incubate the macrophage with LPS, you have information of this band. Leishmania amazoniensis band has another nature, and interestingly, LPS plus Leishmania amazoniensis, the permanent band is this one, which is probably P50. What we can see here is in superficial stage that LPS plus Leishmania amazoniensis incubated with different antibodies, you just see the value of P50. So somehow the infection leads to P50 dimer that is able to probably compete with 6550. Here, we decided to make some luciferase assays. In this construction is luciferase genes that is controlled by NF-kappa-B binding sites to repeat 6 times. Okay, so when we treat the cells macrophage with LPS, we have a luciferase measure. That's quite important. Leishmania doesn't do much, but Leishmania amazoniensis plus LPS there is a reduction. So it's a kind of corroborates our previous results. And so we'll talk about inosol, NOS2. You see that the RNA levels of inos is increased with treatment with LPS, but is decreased when you have the infection, which many must miss with LPS. You can also see that in Western blot assay and expect hydroxide levels are increased with LPS and reduce to have infection plus LPS. So we kind of a context that there is a repressor of transcription expression mediated by P50. So the promoter has several transcription binding sites. And of course, NF-kappa-B is quite important. There's some repeats of NF-kappa-B binding sites. There is a site of overlapping NF-kappa-B and start site and just start. So we got 2 luciferase constructs. Luciferase constructs that has an NF-kappa-B start 1, overlapping 1, and another construct that just start 1. When you treat the cells, macrophage retrospective with this kind of construction, and with the inducers here is the TNF-alpha, gamma interferon, and the LPS have a high level of luciferase signal, and that is reduced also half when we affect Leishmania amazoniensis and treat the inducers. And with the start 1 construction, don't see much, so that makes the point that the sites are relevant for hormones. So here in fluorescence state, you see that in Leishmania infection, what you see is a P50. It's mainly in the cytoplasm. You see the Lopes, the nuclear. You have the merge, is happy. When you have the infection, you see that P50 is the nuclei of the macrophage and the merge here in the infection. If you measure P50 contents by watching blood, let's say you use a nuclear extract, you see that infection leads accumulation of P50 in the nuclei. Then we decided to perform some immunoprecipitation, chromatin immunoprecipitation assays, using the ineffective binding sites of the inos. So what we did was precipitation chromatin precipitation used anti-P50, and you see that in the context of Leishmania mastoides infection, there is a high level of P50 in the boundary private world. For the Leishmania mastoides, blood LPS should have P50, and the UPS, LPS are one that we don't have that much. If you study with this chromatin immunoprecipitation assay, now use another antibody for this patient, that's anti-B65. You can see that Leishmania mastoides, the infection, doesn't do much in terms of B65 because of inos flora. Leishmania mastoides plus LPS will have more, LPS alone will have significantly increased levels of P65. So this work was carried out by Teresa Calegari Silva, Durahel Massey, Durahel PhD. So now what I'd like to show is how these P50 diamonds are formed. And one thing that's known about Leishmania mastoides infection is that Leishmania mastoides is able to induce PI3 kinase survival pathway. And you see here the picture is the activation of PI3 kinase that leads to PKI1 phosphorylation, AKT phosphorylation, and that leads some survival rate of the cell. So Leishmania mastoides is able to induce PI3 kinase pathway, which is a quite interesting adaptive process in terms of the Leishmania is able to increase the lifespan of macrophage and begins time for purification of the person. So while you are talking about PI3 kinase, you are talking about PI3 kinase because there was this work in JBC some time ago that shows that once PI3 kinase is activated, and then there's phosphorylation of AKT phosphorylation, GSK2 beta, and this phosphorylation actually inhibits GSK2 beta. This inhibition prevents P105, which is the precursor of P50, of phosphorylation in the serine 917, and the inhibition of this phosphorylation leads to the processing of P105 by proteasome, leading to the formation of P50. And so we test this hypothesis in the context of the Leishmania mastoides infection. And this Western blot, you can see that during the infection, there is a decreased level of phosphorylation of the serine 907 of P105, which is the precursor of P50. And there is a phosphorylation of GSK3 beta, serine 9, which is the residence that is phosphorylated by AKT. So that is showing that GSK3 was phosphorylated by AKT, and by that, in place so there was inhibits the phosphorylation of P105. So we test further this the involvement of PI3 kinase AKT pathway, and you see the JavaScript assay if we infect the cells and treat it with inhibitor of PI3 kinase, there's a decrease in the signaling in the sign of NF-κB dimer. And you see here that's a nucleus tract and Western blot. So the incubation of the inhibitor of PI3 kinase decrease the levels of P50 in the nuclei of infected macrophage. So then we tested by chromatin immune precipitation, say, in the context of inhibition of PI3 kinase. But see here, again, the readout is the promoter virus. And you see that Leishmania amazonensis, the infection, there's high levels of P50. When incubated inhibitor, there is decreased levels. The same with the other PI3 kinase inhibitors, not binding. So we have this inhibition. And when you hit the AKT1, the same thing happens. We carry out some knockdown of AKT1 in macrophage. So you see by SH signs of AKT1. And when we infect those macrophages, like side by AKT1, there is reduced levels of P50. So that's what you have with this kind of scheme showing results of we found in time. So some papers show that this homodimer P50, in order to promote gene repression, is recruits HDAC1, which remodeling, remodeling enzyme. So that in the model of HIV latency, for example, and also in hepatocytes. So we decided to approach the possibility that P50 homodimers in our system is a kind of also recruits HDAC1. So here is a very general and simplified mechanisms of gene activation of the chromatin, the X chromatin by acetylcholine transferase, and the repression by some HDAC1 that acetylates several residues of any terminus histone. There are several classes, and I just know all of this for example one that is found in the nuclear cells. So when you incubate macrophages with Leishmania amazonensis, and you ask for the levels of HDAC1, you see the nuclei of infected macrophages that are increased levels of HDAC1. You can see the method is also finds signal results. It's the same quantitative, there's a quantitative PCR. And here we prospect the macrophage with construction of the promoter of HDAC1. And then we effect and we see that this signal is very strong. So the infection actually activates the promoter of HDAC1. We explain these results. Okay. Here I just wanted to call attention that we are talking about Leishmania amazonensis, but if you use a lot of Leishmania lesion, which leads to the canonical pathway P65, P50, you see that the nucleus tracts of Leishmania lesion will have the same levels of HDAC1, you don't see the increased level of HDAC1 that we observe in the Leishmania amazonensis. We also carry out some chromatin immune precipitation assays with the promoter of HDAC1, and the main transcription factor that leads to the transcription of HDAC1 is SP1, and we see the infection will have the influence of is SP1 in promoter of HDAC1. So those fluorescent assays, so the control, and you see in the infection there is a convergence of signals in the nuclei of HDAC1 and P50 in effective macrophage. It had just 1 hour of interaction. Okay, so we also carried out another set of experiments of chromatin movement station assays. I just tell you again that in the IMOS promoter, if effect cells well measured, you will see difference in the HDAC1. You will carry out some co-precipitation assay with HDAC1 and NP50, so that points that the complex is there. And we search for this exotic mark, this acetylation lysine 9 in histone 3, which is a mark of transcription activation. So when we affect the cells, this mark of transcription activation, the ionoscope work is reduced compared to before. So can also carry out some science of HDAC1 in macrophage. You see some problems. You see that the infection indexes in the number of parasites that you find 48 hours after the infection is reduced in the context of the science of HDAC1. And also the level of nitric oxide is increased when the silence cell for HDAC1 is infected with Leishmania, can explain the production of the parasite index. So here we find these cells that are knocked down by for HDAC1. There's a reduction of P50. And there is an increase of histone acetyltransferase, CB-300, is the most known histone acetyltransferase. So you have infection of silence HDAC1. And there is increase of this activation genetic mark in the loss. Okay, and so this work by Silveira and also other authors, they show a kind of figure that resembles the Hanseníase. You have this anatomical profile, and you have this other profile that is when there is a response is very strong. And what we did in order to test what was seen in the lab was to investigate in the lesions of patients with Leishmania, patients with with effective Leishmania disease, there is no natural response, compared to patients with Leishmania masomensis. And you see the list of patients. And what you see here is immunoperoxidase. It's a representative immunoperoxidase analysis of the patients with a NASH response. That is, we have measured non-expressing cells expressed in HDAC1 compared to the lesion of patients that are not in a NASH group. So we have a much more cells expressed in HDAC1 in those patients that are not expressed. So that's interesting. So it is our what is happening in our system. So then we decided to, that was during the pandemics, our group started to think about how to continue this work and how to widen our horizons in terms of investigating this interaction with the and the macrophage. So one thing is, of course, that there are several questions, relevant questions, which factors I actually use HDAC1, I actually use a kinase, I use a P50 formation. And in order to respond to this, a kind of very complex context. So we decided to limit our universe using extravascular vesicles of Leishmania resonance. So actually, we bet that the incubation of extravascular vesicles of Leishmania resonance could actually lead to some phenotypes that we observe in our investigation. So it will be a kind of easier to approach some candidates. So what you see here is a proboscideote, and you see the vesicles that are released by this. In electron microscopy, you see the vesicles. So we get some of our preparation. And you see here those vesicles, you have the grade, you have all the pictures, but those get the feeling of the vesicles that were in. So that was a very tedious work in order to get the right protocol for the potential of these vesicles. So it was modelized 1 year. So what you have is we collected the cells, we incubate for 6 hours, and we work with incubation in PBS at 26 centigrades for 35 receptors, 35 centigrades. And then we perform a series of centrifugations and centrifugation, and we get our with extravascular vesicles. And we by HA, we can see the concentration and dispersion by meaning of our vesicles. And here is a very recent preparation that was carried out by Jorge, Sul, and also Letícia. It's left. And you see that there is a main idea of continuity nanometers of our vesicles. Is a kind of cube, you can see here. And then we explore this vesicle in terms of integration. Of course, the first question was those vesicles would reduce each technical expression. So by QSR assays, we see that the 35, the vesicles are located at 35 centigrades incubation. They reduce the mass of George background. So we can work with more. Also, those vesicles, they are able to use arginine as well. The vesicles is not a novelty. So all the groups more traditional line, with traditional resonance, and extravascular vesicles also show that. So we are tuned with all the groups that is good. Also, those vesicles they use IL-10, which is also interesting. And we expected that the preservation of the vesicles and further infection of the Leishmania would lead to increased level of parasites inside the cells. So the treatment of the 600 vesicles per cells or 1200 vesicles per cells leading to more or less the same level of increased infection index. The same with the THP1. Those are human macrophage, those are human macrophage, H1. And we have this not shown today. So in collaboration with Saliva, we carry out some experiments in order to test that those EVs will lead to extracellular neurophilic traps, which when the neurophil is in contact with pathogens, is able to suffer several modifications, morphological modification, and it expels the intracellular contents, the nuclear contents, and traps and some case kills the pathogens. So this work was done in Village Lab by Jean, also my lab. So that's the pivotal work published by Elvira some time ago, showing the Leishmania was amazing. This actually fields for some of crops like ICB. And I just now was showing some results, like the full thing. So we incubate neutrophils, human neutrophils with the vesicles, and we have 300, 600, 100 neutrophils. The positive conversion is a PMA, and see those vesicles are able to induce these nets. And this beautiful picture showing that the vesicles, they are able anti-LPG, and you see those neutrophils and those the vesicles in contact with neutrophils, so the merge. And you see here is the net formation, it's a long net. So in order to expel the nuclear protein, some epigenetic modification for the neutrophil. And one of those was stimulation of H3, which is a kind of opens the chromatin. And so this open chromatin is a kind of okay to be expelled by the neutrophil. So you see the fluorescence of anti-civilline H3. So the vesicles here, the DNA, and the virtual of the those foods. So one thing is okay, our vesicles are able to use nets, but now other vesicles, other organisms will use nets as well. So we use Herpetomonas as tip. Herpetomonas is related to Leishmania, it's a chromosomatic but not pathogenic. So we prepare the EVs from the Herpetomonas, and you see here that Herpetomonas is not able to use nets, so the kind of specificity. Of course, there are several patterns without major division will do the same, so we'll do that. And that's some other results here. So one important result, I guess, is that this incubation of users, but some are vesicles in the neutrophils needs some killing of the parasite itself. So that's a kind of thing in terms of the evolution of infection. That's a good killing. It probably could be an adaptive process of mimicry of the infection. So we have the questions that we're still working on, which project actually is population. We still don't know in this context how exactly is population, the promoting is activated, but how is promoting is activated. Our other genes are present via P58-1, there are some. There's a very simple collaborator, the professor here, she could talk about the 7% results based on RNA-seq experiments performed with the macrophage, the science by H-DEC1 set of macrophage. And that's quite interesting. Of course, my interest is whether it's a genetic mechanism between by parasite or in the ETs. And the main thing is what's the content of the ETs, what's the cargo of those ETs, and how they lead to those phenotypes that we get today. Have several people to acknowledge. Cristina Calegari Silva, from Professor from UFRJ, not really access to data, but work to use science and other things. Kind of leader just to share, she was in my lab, in the States. Nicholas Fazel was a international collaborator in Cidade and Elvira Saraiva, João Pereira da Silva, of importance is net experiments, and of course, ICB-IBCCF and the Swiss National Science Foundation. Also, in my lab, Joana Massolidina, Ulisses, Letícia, and again, so for the São Paulo, was our campus, and with the hospital, we have near here, that's the vein. So, thank you very much for your attention.
Thank you, Dr. Ulisses. As is customary with the webinars, we first open questions to students and postdocs in the audience. And Lisa, if it's okay with you, I'm going to open first here in Rio. See if there is someone here. We actually have one question. I will just ask for the ones who have questions to come up front so they can be captured by the camera. Okay. Thank you.
Ulisses, thank you for the presentation. It's very nice. I actually have a bunch of questions. Some of them you already addressed.
You get one.
I know.
Okay. No, I know you. I'm sure.
I know. Yeah, you actually addressed that. Some of the questions I was going to make are also open questions for you, so there's no point. The first thing that came to my mind was because I imagine that you first infected macrophages with Leishmania and then you did the treatment with LPS, TNF. When you think about the prevalence of Leishmania, there are other infectious diseases, parasitic diseases, malaria, which can cause a huge change in the immune response phenotype. So you know that malaria causes a very strong Th1 phenotype. Because the beginning of my question was whether it would make a difference or not to pre-treat the macrophages with LPS before infection, then people that have malaria and that can also get infected with Leishmania after that, would the Leishmania infection be able to change the phenotype and maybe cause maybe prevent the severity of malaria infection in the sense of reducing the T4 response, or the malaria infection would be able to block the epigenetic modulation of the Leishmania infection?
Well, so we are dealing with a in vitro system.
Yeah.
So we did the Leishmania plus LPS and also the Leishmania. The results are quite simple.
Okay.
So there are no much difference. Regarding to malaria, I don't know. Of course, there are some papers that show genetic modification in hepatocytes, for example, and those modifications are quite important for formation of the growth factors. So, but then I cannot say anything. So, in the spectrum, the genetic modifications in the interaction pattern, of course, of course.
Yeah, because I was imagining whether the malaria infection would cause such a strong, in case it occurred first, it could cause such a strong epigenetic modification of not only the macrophages but the entire immune system that could maybe prevent the effect that Leishmania has, or the other way around. I don't know.
All right, thank you. If we don't have any more questions here, Luisa, are there questions from your side?
Not yet, Bruno.
Okay, so let's just open for the general audience then. So I have a question here from the camera up front, so everybody can see you.
Well, that's my first experience in a hybrid systems. It's really thought, and during your talk, I had the necessity to see the kinetics, because I don't know what is the half-life of a modification that the picture, and that had to do with the end of the second part of the talk, because then you start discussing effects that are induced by chromatic. So the question is, do you think in your system, this is a very, very biased effect by the set stage, or this is something that is sustained by the massivals? Of course, we cannot do it as a massivals, but it is important for us to know if this is a transient effect or this is a long-lasting. So that was my first question. The second has to do with your introduction, because you made such a beautiful review of the complexity of the system, the regulation, and then at the right side of the slide, you said, well, this is the adaptive component. The adaptive component adds another level of complexity of the system. But if we are to think about what happens in the patients that you are examining, you should expect to have, some sort of importance of the T cell recruitment, cytokines transposition. So I don't know what are your thoughts, because since we don't know anything about the adaptive contribution, and of course they should influence the phenotype. And you are showing that conduct one is actually unregulated, although you probably have a T cell component in the liver. So it's just an opportunity to hear your thoughts.
Thank you for the questions. So the first questions had a limitation because I didn't very features. So you have very window of observation in fact incubation. But some of the main points incubation, too long incubation, we are able to see the incubation, complete formation, and the nuclear of the infect cells is interact with the muscular system. So it's very early infection. If you see there's not a real kinetics, but if you see the geometries, there's an issue in the points observation. So my feeling just opinion is a kind of people, in fact, could be just take to wait for the classification. But on the other hand, when you look for the tissue, the symptom biopsies, that is there, in that is long-term expression. But if that one is there, we want to search for P50, but just for the our biology from this stoichiometry, in that group of patients is full of parasites. There's no related simple response. There's no diameter from the flowing models. So actually, the parasite is constantly trying and probably is keeping the leverage that visits. And then also that makes another possibility that's immersibles, because those lesions that are just full of immersibles, they don't need a reinfection to be so probably beside the copies for clean, this could be nuclei, would be very easy. So those are hypotheses. Of course, we can kind of test them in vitro by mass dose preparation, macrophage and series.
This was a profile of the T cell profile of this
No, there are several groups that show that CD4s there's a depletion. There's a depletion of people from North Brazil and Chagas. They have the main group of patients with diffuse contamination. They have a depletion, some depletion. Okay, so that's one point. The second point is sorry?
The adaptive.
The adaptive, yeah, that we need in vivo experiments. So in order to check. So we have previous and then nothing to have often taken. But definitely deviation on in vivo experiments.
Okay. Luisa, do you have any questions from your side?
Hi, Chris. We don't have questions in Zoom still.
Okay. So, and I have a question, but I don't know if someone have a question in the here. So it's a curiosity question. Because you of course P50 and HDAC1 are pressures mechanisms, you show that. But when you show the first part of your presentation about P50 and the role, the impact on INOS and also nitric oxide, with in that experiment that Lucas was talking about with LPS. I was curious about what happened with arginates in that setting of experiments.
Yeah.
Because, I mean, the L. amazonensis infection is triggering a repressor mechanism, but it also has it triggers expression.
Yeah.
So how this works I was really curious about the LPS assay, but at the HDAC, you didn't come back to that house, isn't it? Into the INOS expression. I don't remember. Yeah, you did.
There is a silence HDAC on the page. There's an increased INOS expression.
Yes. Okay.
In the network stack. So, one thing is we have P50 information. It's like there is a recruitment on HDAC1, but you must think the chromatin in the landscape of genetic modifications separate. So there is this code, there's a barcode that tries to explain how some loci of the chromatin expressed, some are not in some conditions. So what I'm saying is not if you have P50, some promoters will be occupied, but not every promoter, okay, which has 80K binding site will be occupied, because that will depend on that landscape, some ventilations, a lot of kind of stuff. So in order to answer that, you need a more powerful approach with chipset. So then it's occupied or not. So you know the chromatin, you have insulators, you have another several topological structures that could delimitate it. Even if you have activation of the spectrum, that side, that region will not be occupied or whatever. So arginase is probably some other size, probably not local, is probably prone for activation. And in the context of P50. So and also
it could be independent.
Could be, and that's it's a very complex. That depends, as I said, that depends on the landscape of the genetic modifications. And another thing is we talk about HDAC1, but it's very simplified way to think about the role of HDACs. Because one thing HDACs is the essentially is not only histone, essentially several proteins. HDAC1 we are looking because it's a mainly nuclear one, so they probably the basis for this thing. Another thing is HDACs, they actually There's very elegant papers showing that HDAX actually helps our lipoproteins to localize in the right way to promote restriction. So it's not just this thing about relaxing or protect fertility, it's much more than that. So we have a very reduced, just promote granules and try to get the yeah. Sure.
Okay. Thank you very much, Ulisses. Was very nice. I love the extracellular vesicles. I think it's a great approach.
Probably
And,
the next presentation.
Really interesting. And you were able to reproduce with the that's amazing. I think you are going to have a lot of very cool, curious things coming from that, because you can really restrict the things that are triggering them. That's great. So thank you very much. Thank you, Ulisses. Thank you. Now, we can